Hey, what's up, guys? This is Cheng here. So today, let's take a look at this very old or classic problem, number 259, three sum smaller. Even though it's like very old problem, but I think I find that's kind of interesting. Okay, so you're given like an array of integers, right? And it could be either negative, zero, or positive, and it asks you to find like the three distinct like numbers, the basically which consists of a triplets, whose like the sum of those three numbers is smaller than the target. And yeah, that's the question, right? And the follow-up is like, can you solve it in the O(n) square time? So today we're gonna focus on this one because if we don't care about the runtime here, I mean we can simply use a brute force way, right? Basically just to have like three nested for loops, right? To loop through all three numbers, and then for each combinations we just compare, and then we just increase. Okay, that's it. So I think a better way we can do it, a better way of doing this is that, I mean, we can utilize the hash tables to store the previously two numbers results. Okay, and for the two number pairs who has the same sums, we can simply store all the number into one key, which will be increasing the count for that two pairs. I mean, we can so that we can improve our runtime a little bit. But I mean, for that solution, the worst case scenario is still O n cube. But since we have like a range here, right, and we have a bunch of like uh, random numbers here, I mean, it's very likely that a few pairs can end up having the same sum, so which can help us reduce some of the runtime here. And cool. So let me try to implement that one first. Okay. So sorry about my Chinese input here. So so the first one is going to be the numbers, right? Like I said, and we're gonna have like a few, like the sanity check. Like let's say for example, if the for the basically if the n is smaller than 3, okay, and then we simply return 0 because there's no way to get a triplet in that case. Second, I'm gonna have like basically gonna have a two sums, okay, two sums dictionary, and I'm gonna use the default dictionary like int, okay, and then uh basically I'm gonna start as the third element, okay, because that's the first one that we might get the the three triplets. Sorry, we might get the three numbers, which is the triplets, okay, and then basically the two sum dictionaries stores I mean all the two pair sums we have seen so far, okay. And since we're starting from the third one, let's add the first two to the two sum dictionaries first, okay? So it's going to be nums 0, okay, plus nums 1, okay, equal plus and then plus 1. We increase it by 1, okay? So basically the way I'm doing it for the current one, the current number, basically if for any two sum, okay, for any two sum in the two sums, okay, if the two plus nums plus current number, okay, is smaller than the target, okay, and I just increase the answer. I just increase the answer by what? By the answer plus whatever how many appearances, how many counts we have for the current sum here. Okay, which means let's say for the two sum, let's say the current one is like the current number is 2 here, and let's say the target is like is 5, and let's say for the previously the two pairs, right? Let's say for the two pairs we have a sum equals to 1, which count is equal to 3. Okay, that means uh it means that we have three pairs that whose sum is 3. That's why with those three pairs we can just simply uh consist we can simply form like 3 new triplets. That's why we do an answer here. Okay, so that's that, and then later on we just need to uh basically update our two sums with the current number. Okay, basically for odd numbers in range of I. Okay, uh two sums. Okay, nums I plus nums j. Okay, plus 1. Okay, that's how I update the two sums, because with the current with the new number nums I here, we will have like this many new two sum pairs. Okay, here in the end we simply return the answer. Okay, I think this should just work. Okay, cool. Submit. All right, so it works. Okay, I mean, as you guys can see here, right, the time complexity for this one, actually the worst case scenario is also still like 2 square. Sorry, still n cube, because for the outer loop is n here. Okay, and here this part is n, right? But this part is also is always n. But for this part, the worst case scenario is that like every time we're adding like a n new element into the into this two sums dictionary. So the worst case scenarios will have like a n square here. That's why the worst case scenario for this one is still n cube. But like I said, since we will have like a most likely we'll have like many pairs who have the same sum values. That's why this part I think it's between the n to the n square. Okay. Cool. So that's the first approach. Okay, it's not a strict like n square solutions. And let's take a look at a better solution, which is a strictly n square. Okay, so which is sorting. Every time when you guys see like any problem that's asked you to find any triplets, okay, or any pairs, triplets, or anything that's like satisfy a condition, right? The first things pop out of your mind is always sorting. Okay, and I think a easier version for this one is to find two sums smaller. Okay, basically find the two sum like the pairs whose number is smaller than this one. So for that one, we always do the we also do the sortings, and basically for that one, uh, we do the sortings, and then we just have a left and the right pointers, and then basically if the sum for those numbers is greater than the target, right? And then we shrink the target. Sorry, we shrink the right pointer to the left, because we know we need a smaller number. Otherwise, we move the left pointer to the right side. Okay, because the number is they're already sorted. So same idea for this one, but the only difference is here now we have 3 numbers. Okay, so with 3 numbers we can still utilize the same concept, but we just need to do a little bit extra work here. So like I said, let's do a sort. Let's sort this number first. Okay, now we have a sorted numbers, and we have an n here that equals to the nums here. Okay, So, and since I already told you guys how can we find a two some smaller numbers by utilizing the left and right pointers, and actually we just need to treat that one as a sub problem, and instead we just need to have fixed one number first, and then we just use that problem, use that solution to solve the rest two some smaller problems, because that like two pointer is like O n runtime, right? So basically this is what I mean here. So we have a n here, okay? We have a range like n minus 2 here, because that's going to be our starting point. Basically, uh, with the current number here, with current number I here to the n number here, we want to see, since the current number I is fixed, okay, and we just want to know like uh, how many two pairs, how many pairs that how many pairs that between the current I here, between this one and this one, that satisfy the target, right? So how can we do that? We just simply do you know, since we already fixed this one here, so the left will be what? Will be I plus one, okay, and the right is always the n minus one, okay, and we just do a pointer while left equals to right, left smaller than right, okay, and now we have three numbers here. If the nums I plus nums left plus nums right, okay, it's smaller than to target, okay, uh, okay, then what do we have? Okay, uh, okay, so if the current one, if the current left and the right satisfy the current condition, what does it mean? It means that, since remember the number is sorted now, right? So it means that from here, from the left plus one to the right, for all those kind of right elements, they're all satisfying the, they're all satisfying this target, this condition here, because currently the right one is the biggest one, the biggest number. Since the biggest number is also satisfying this one, so anything that's smaller than the current right is also like satisfying our conditions here, so that we don't have to worry about anything between those. Okay, then how many options between those, right? We have like right minus left. So that's how many pairs that between the left and the right will satisfy this condition. Okay. Then so after this one, it means that okay, we have count all the pairs, like right, starting with which have like I and L with different different right here, right? That's why we can simply move the left forward, and we just want to check, okay, with this one, with that one, can we try a bigger number of the left to see if this one's still satisfying that? And then we know, okay, if that's still satisfying the condition, then we know from here to from the here to the end, we are gonna have like a few more valid pairs here. Okay. Otherwise, right, if this condition doesn't meet, and then it means that the number is too high, it's too big. So we need to find a smaller number. So how can we find a smaller number? We just move the right to the left. Okay, that's how we try to find a smaller number. Okay, yeah, and here in the end we simply return the answer here. So this should just work. Yeah, let's see. Yeah, as you guys can see, this is much faster because we have a on here. We have a on on the outer loop, and here it's simply like uh, another on here. So that's why this solution is O(n) squared. Yeah, so it's pretty smart, right? By using like sortings plus, plus like two pointers to solve this problem because, since like, I think I'm repeating myself, but basically just to recap, right? We're using like, we sort these numbers first and then we fix the first number first. We fix the first number and then we try to find, like for each of the fixed number here, we're trying to find a place, a number, right? Like a pairs that satisfy the current conditions. Since the numbers they are sorted, right? If we find a left and plus right that is satisfying our conditions, which means that everything like left plus like anything that's from L plus one to right, okay, to right, they're gonna they're gonna satisfy the conditions as well because the right one is the smallest, is the biggest one. Okay, yeah, so that's how we can skip all these things because we know they're already sorted, and then we just move the left forward. We try to find if we have another valid starting point. Okay, and then we keep doing it, right? And if there's doesn't satisfy, then we try to lower the right pointer so that we can have like a smaller number in that case. Cool. I think that's it for this problem. Yeah, thank you so much for watching the videos, guys. Stay tuned. Like always, thank you. Bye bye.